Good day, fellow. I'm going to continue with the concept of photoelectric effect. Don't forget that the word photo means light. The word electric has to do with electrons. Then now I'm going to explain the concept of what? Of intensity as well as frequency. Intensity. The word intensity has to do with brightness. Bear this in mind. Last time we said if the frequency of the light is greater than the threshold frequency, then the electrons will be ejected. But if the condition is like this, no electrons ejected. See, and now we are going to consider our frequency to be constant. But for this condition, whereby f is greater than threshold frequency, if we increase the intensity, therefore the amount of electrons ejected, or let me say emitted, will increase as well. If we consider this situation whereby f is greater than threshold frequency, but we keep our f, which is frequency, to be constant, then we decide to increase the intensity. Therefore, the amount of electrons ejected will be more. But now let's consider a situation whereby it's like this. Now we keep the frequency to be constant for this condition, whereby now our frequency is less than threshold frequency. What will happen? In this case, no matter how much we can increase our light intensity, for as long as our frequency is less than threshold frequency, no electrons will be ejected. Firstly, the frequency has to be greater than threshold frequency. The way threshold frequency is the minimum amount of frequency for the electrons to be ejected. But now if frequency is less than threshold frequency, no matter how much we increase the intensity or the brightness, no effect will be on that case. Yeah? Now, let us consider the frequency. Now we have the frequency. What will happen if now we increase the frequency? We increase the frequency of what? Of the light. We increase the frequency of the light. Then we decide to keep the intensity or the brightness to be constant at all time. We increase only what? The frequency. By increasing the frequency, what will happen? Our electrons on that case will gain more kinetic energy. Somehow, by increasing the frequency, then the kinetic energy of electrons will increase as well. Then yeah, we also have this formula now. By increasing the frequency, will increase more of what? Of kinetic frequency, of kinetic energy. Now let us consider a case where now we have this formula. Let's say energy of photon plus work function together with kinetic energy. See? Then this is energy of a photon. This is just a work function. Then this one is our kinetic energy. Then remember, we have a threshold frequency. Now I introduce another term now, which is work function. What do we mean by the term work function? It's the minimum energy required for the electron to be ejected. See, the minimum energy required for electron to be ejected. This formula, we can further write it like this: HF, this one H with the threshold frequency there, plus 1/2 kinetic energy. You see, this is another format of writing this formula. It can be further written like this: H C plus 1/2 mv square. Now, previously we said that if we increase somehow, if we increase the frequency, what will happen to the kinetic energy of the kinetic energy of the electron? It will eventually increase. This is a diagram of photoelectric effect. It is more like this. Then we have dotted lines here. Then this point is going to be our work function. You see? Then if I had to take this equation, do you see this equation? Then I decide to make my y the subject of the formula. Then I make f the x intercept. Then I make k the y intercept. How will it look like? We want to know what will be the gradient of this graph. Then now look, I now take this formula, which is work, which is equals to work function plus ek. You can also write it like this, it's fine. It's equals to work. Then I take one work function to the other side. Then we get something like this, which is our ek. You see, now my ek, it's on the y, it's my y-axis. Then where is this frequency? Don't forget that W, which is work or energy of a photon, can be represented in a form of HF. Let us leave this one as work function. Then we have EK. You see, now we know from mathematics that if we have something like this, a value next to x will represent what? The gradient. Check. X in this format is our frequency. Do you see? Then our y-intercept is this one. You see, work function. Then now our h, so our m, the gradient, is going to be our h, which is the Planck's constant. What will be this value now? This value will represent what? Your work, sorry, your threshold frequency, the minimum energy that we need for that electron to be ejected. You see, this is going to be your threshold frequency. Then check, as we increase the frequency, what will happen to our kinetic energy? Check here, it also does what? It also increases by time. Now I'm going to take a short example. Let's say if with my calculator,